kind of 5, 6, and 7. So on number 5, and again, understand, you've got the theoretical pH of the acetic acid after the sodium hydroxide is added, right? So start with the reaction. What is going to take place on the reaction on number 5?
Something.
The hydroxide is going to react with the acid clumpy?
Yes.
Yes, so we're going to write this as HA. What are you going to get out of it? Water and the, this is a non-buffered solution, right? So what's the initial concentration of your anions?
0.
0. Now, because this is getting used up, Kevin, start that camera back up.
I already did.
Okay, never mind. So,
Good job.
you can either work in moles or you can work in millimoles. You cannot work in molarity. Okay? So, I did millimoles, right? So you got 2.5 millimoles of your acid. You have 1.5 millimoles of your base. So what's going to run out first? Base. You're going to go minus 1.5, minus 1.5, plus 1.5. True?
Yes.
0, 0, 1, 1.5. At that point, slam it into the Henderson-Hasselbeck equation. pH equals pKa plus the log of your anions over the concentration of your acid. Good?
Yes.
Can we get a range? Just for the fun?
5 should be around 5.
Whoa.
Okay.
That's great.
Okay? Now, what's the only difference on number 6? So, is the reaction still going to be the same?
Yes.
Yes, the hydroxide is still going to react with the acid. You're still going to get water, and you're still going to get the anion. You still have 1.5 millimoles of your base. You still have 2.5 millimoles of your acid. But what's the difference? You have to have the millimoles of your anion, okay? Right? Okay? But that gets a little bit sketchy, but not bad, because you know the mass of your sodium acetate. You know it was put in 25 milliliters, so then you can find the molarity and then multiply that basically by 25 milliliters. So the number, if you work in millimoles, okay, listen to me, if millimoles are your jam, which I highly recommend, the number of millimoles of your anions should be 0.46. Close enough. Okay? Now, it's going to be the same thing. You're going to go minus 1.5, minus 1.5, plus 1.5. Okay, it's the exact same process. So your answer to number 6 should also be around 5, but a little bit bigger than your answer to number 5. Yeah, your answer to number 6 is closer to 5 than number 5 is. Okay? And then 7 is the exact same thing. Okay? So, but you're going to have a lot of millimoles of your anion. So your answer to number 7 should be around 6.5.
Oh, joy.
Okay? Should be around 6.5. Are we good?
Like on those 3 or the assignment?
One of those 3.
I'm good.
Okay, anybody have any other questions?
8.
Okay. So, if you look at what's happening on number 8, because it asks about what's going to happen in that trend on 5, 6, and 7, right? So, Kevin, start with this. What's the trend on 5, 6, and 7? What's happening to the pH?
Going up.
It's going up. What's the only way mathematically your pH can go up?
Concentration, hydronium goes down.
Concentration of your hydronium ions is going down. Okay, that's it. It's the only way it can happen, right? So if you look at, again, how you calculate Ka, which is the hydronium ion concentration times the anion concentration divided by the concentration of the acid. On 5, 6, and 7, what stayed the same?
Okay, and your acid.
Right? Those numbers stayed the same. Did not vary, right? But what happened to the anion concentration?
Goes up.
So therefore, to create the same Ka value,
Hydronium goes down.
there you go. That's it. That's your magic answer.
So that makes sense. Basically, what he's asking.
On that blue sheet, questions 2 and 3, both of those answers should involve a 1 and an 8.
Oh, I have 26 X ones there.
2 and 3. Both of them should involve a 1 and an 8. And they should be side by side.
Oh, sorry, what?
I know.
Huh?
Nothing, never mind.
Oh, good grief. That's what you said?
It's a bad day, but BAD, bad and dumb.
I was looking at
Bad and dumb, or just bad?
Bad and dumb.
Yes,
at 1 and 2.
Yes.
It's just an acronym.
All right. Anything else?
used to describe maybe.
Make sure your graphs are labeled. Make sure, what, Charles?
Question 18.
Okay. You have NH3 and you have NH4, right?
Yeah.
What can you find? Can you find the Kb value of ammonia or can you find the Ka value of NH4?
You can find the Kb of ammonia.
You can find the Kb of ammonium and you can look up that number. Okay? Now, what do you know? So this would be the Kb, this would be the Ka. When you multiply those two numbers together, what do you get?
1.0
Times
e to the negative 14.
autoionization constant of water, right? So the Ka times the Kb has to equal, right? Now, look at this. Your ammonia is going to react with water to form NH4 and hydroxide, right? True. NH4 reacts with water to make H3O.
Oh, yeah. Sorry, I was confused on the first one.
And NH3, right?
Yes.
So look at what has to happen. First off, look at which one is bigger, the Ka or the Kb. Then look at the two reactions that generate those Ka and Kb values. That's how you find your answer. So you got to do like a little bit of a comparison of those Ka and Kb values. One's going to be noticeably big, one's going to be noticeably small. Okay? All right. Anything else? Once, twice, sold. Get those handed in. Take the graphs
He said
to
no
the
more.
bag.
Blue or white on top?
Blue on top,
Oh, white and then grass.
blue, white, grass. On two, great.
Look at the value. It's gonna stay mostly as. Wait, is that for the Ka?
As ammonia.
That's the Ka. That's the.
It's gonna be ammonia.
It's gonna be ammonia. No, the 1.8, the base. What's to be the base?
No, it doesn't.
Yes, it does. It wants to be the
It
acid.
must be the acid.
What order do you want it?
Because the acid value is smaller, so it doesn't want to split apart.
Sorry, I didn't hear that. I was helping Holly.
One,
I was being generous and kind.
Blame.
Yeah, 5.5
Oh, yeah.
is negative
It's the
10.
KA.
That is the KA.
Because NH3, the number that's in the textbook,
The bigger
is
the number,
the KB,
the more,
less
the
it doesn't want to
I'll be there at
the bigger the number, the more it wants to be associated.
No.
Yes.
Yeah. Wait, that's the KA.
And yes, the KA, the more,
So it does, yes.
the higher it is for KA, the more it wants to
This
separate.
doesn't
I
want to
was not
dissociate.
processing.
So
Exactly.
it's going
So
to
it's
stay as
saying the acids, they're saying the ammonia.
Okay, I was,
I
thought you were doing the ammonia.
No, we're good, we're good, we got
This,
this.
so
Besides
this,
the fact that it takes me forever
this
to
is
fill out.
ammonia, this is ammonia. I thought this was ammonia.
It's only
No, I was
scale,
thinking the
so I'm
same
just
thing.
so
Agree part, yeah.
Good, glad we can come to this consensus. Oh, yeah.
I'm liking this idea.
By the time we get out.
There was like one of them where I got
We're
zero
gonna
one and it was.
Yeah, it was like 2 problems.
Oh, they're gonna be.
What's the order of
And
staples?
it's not even detailed. Okay, now, let's talk about tomorrow. I'm not gonna be here tomorrow,
What the fuck?
okay? Because I gotta go down to Winfield, it's my Kansas City for the year thing, it sucks, but I gotta be gone. So here's what's gonna happen tomorrow.
Oh, no, I have to.
Horrible. Just threw that out there.
So, here's what's gonna happen. A lunch, walk in, you're gonna have the quiz, okay?
Wait a second. Oh, shoot, we got
We got a quiz tomorrow.
So it's not over.
It's calculation heavy, I remember that.
Calculations, I'm gonna, of either, just basically like that blue sheet that you just did. If you-
I literally can do
Okay,
this.
or on that buffer assignment, the big bad buffer benzene, go back, if you can work those problems, you can do the quiz. Okay, literally, you can do the quiz, okay?
Is that the yellow sheet from?
Yes.
Do we have to name 7 acids?
No.
Acids now?
Do you not listen to a word I say?
Yes.
You do not have to name specifically any of the strong acids. What I'm going to do is I'm going to give you a list of compounds, and you tell me, are they a strong acid, a strong base, a weak acid, weak base? Okay? So when in doubt, you have a sheet of paper that says, oh, here's the strong acids, here's the strong bases, here's an example of some weak acids, here's some example of weak bases. Look at those, okay? Ammonia, weak acid, strong, ammonia. Weak base, strong base.
Weak base.
Weak base, you just did it, there's a KB value, okay?
We're gonna be okay.
Strong basis, that's the OH.
Okay, the next thing that's
Yeah.
gonna happen
Oh, wait, yeah,
is that
right.
you're going to be given this sheet of paper. This is the preparation for the next lab. What you need to do, okay, is that there's 5 different solutions that need to be prepared. Like, you need to prepare a 30 milliliter of a 0.06 molar solution of magnesium nitrate. I've given you the molar masses. You do not have to calculate them. So what you're going to do, and I tell you this in the instructions, on another sheet of paper, you're going to say, because this is what's going to happen on Friday, you're going to say, hey, I'm going to go in and I'm going to have these bottles out there. You need to know how much the magnesium nitrate, potassium hydroxide, all of these that you have to measure out to prepare this volume and this molarity of these solutions, okay? So, down here to be handed in for part 1, calculations showing the preparation of the 5 solutions. That's what you want to have done, okay? Now, the balanced net ionic equations, which I'll explain in just a second, and then calculations of QSP, which I'll explain in just a second. So tomorrow, take the quiz. It's front and back. But there's also a lot of calculations. I give you lots of space, okay?
Is there any multiple choice?
There's no multiple choice,
Good, good. I'm okay.
okay? It's mostly calculations, okay?
Berg, this is the only class I've ever taken where I hate multiple choice more so than open answer. No, but
Okay, anyway, now, here's the story. So if you look in the back of your book, and I know I only have 5 minutes, so I gotta cram this through. If you look at the back of your book in the index, there is a chart that has
Oh my.
Is it the solubility
On
constant
page 1093, says solubility product constants for compounds at 25 degrees Celsius, okay? And it has this deal that says KSP, solubility product. Now, let's talk big idea. What's the only time you use K?
one? No, wait.
It's in equilibrium, right? So, if you notice, and this is what I'm going to show you, if you come down here and you find magnesium hydroxide. Magnesium hydroxide is 1.8 times 10 to the negative 11, okay? That's the value. If you look at all these these KSP values, they are very small, okay? They are very small, just like Ka values are very small, okay? So, I know there's a dramatic flare to pause there. So here's what I'm going to do. I'm going to mix sodium hydroxide, okay, a couple drops of that, and a couple drops of magnesium nitrate. And when I do that, you get this chunky white precipitate. It got clumpy, okay? It got clumpy. So here's what happened. I took magnesium nitrate, soluble or insoluble?
Soluble.
Soluble, because all nitrates are soluble. And then I reacted it with sodium hydroxide, soluble or insoluble?
Soluble.
Now, here's what's important. This existed as magnesium ions and nitrate ions, and sodium ions and hydroxide ions. So this is like at the homecoming dance. We're going to switch partners. The magnesium is going to come over here, and it's going to hook up with the hydroxide.
No.
Okay? The sodium is going to try and bond with the nitrate. So your two possible products, it's a double displacement reaction. You can make magnesium hydroxide or sodium nitrate. Which one of those is going to make a precipitate?
Magnesium hydroxide.
Magnesium hydroxide is. Okay? It got clumpy. If you can find the KSP value for it, that means that this thing is a very, very, very small number. It means it wants to exist as a clump. So your net ionic is going to be Mg2 plus 2 hydroxide, yielding MgOH2. Now, here's the bigger mathematical truth. What you focus on is this. So your KSP is going to equal your magnesium ion concentration times your hydroxide ion concentration squared. Now here's what's different. We've never had to square or cube anything, because everything that we've dealt with so far, the coefficients have just been 1. Okay? Since the coefficients have just been 1, we've only raised it to the first power. Okay, I know South people have to go. So, we'll continue this discussion tomorrow, or on Friday. So, you got the quiz tomorrow, you're going to have that sheet, do the calculations to prepare the solutions. That's what you got going tomorrow. Okay? All right, ready, break. Southeast, you're out. Stop yonder camera. No homework. Other than